Alright, so we're going to continue on to find the probability in each row and each column for the image. I'm using a new image now, this chicken. That's alright. Let's get rid of this. I just typed that. So what we want to do is find the probability for each row and each column instead of just the entire image. So firstly, I'm going to create an array to save them. Or, hold on, we'll finish off this one. We'll convert the numbers we got to a percentage. So just to remind you, if I run this, it'll return a bunch of numbers, depending how frequently each one occurs. So there's 5,152 pixels, and all these numbers here probably will add up to 5,152. So I want to convert them to a percentage, so I can just divide each one by the total amount of pixels that'll give me the result as a percentage. So I can just type, I'll make a new variable for it, so I'll call it 8colors prob. So the probability of each color occurring. And I'll just initialize it to zeros, and I want it to be an 8 by 1 because that's the amount of colors I have. So amount of colors 1. So I'll just run that and make sure it worked. 8colors probability, 8colors prob. Yep, so it's a bunch of zeros. That makes sense because I haven't put anything in there yet. I want to populate these with each one, how frequently each color occurs, then divide by the total amount of pixels. So that's pretty easy to do. I can just copy this, 8colors probability, and I want it to be equal to 8colors frequency, so how often each one occurs, and then I want to divide it by the total amount of pixels, and we calculated total pixels up here. So that will return each number as a percentage. Just run it, and let's see if it works. 8colors prob. I spelled it wrong. There we go. So each thing is a percentage, which looks pretty good. Could multiply that by 100 to get it as a percentage out of 100, but I'm going to leave it between 0 and 1, which is pretty much the same thing anyway. So now we need to repeat the process we've done here, but just for the rows and columns. So first things first, we'll make another matrix to contain them. It'll just be like the same one up here. So I'll call it row prob, I guess. And I'll initialize it to be zeros. Amount of colors, and 1. That looks good, that should be fine. And I also want to get a reference to the total amount of the width and height of the image. So I can do that by typing rows. I want to call it rows and cols. And if I type size and then a matrix, it'll return the length and width of that matrix. So if I run that, yep, rows 131, columns or cols 32, which makes sense. 161 rows all the way down here, and then 32 columns. Cool. So now we're going to do each row. So just start with doing one. We're going to start by calculating the probability in the very first row all the way down here. Then we'll extend it for the rest of the rows. So I'm just going to do a for loop like we did before. R for rows. And I want to do it rows amount of times. So I want to do it 161 times all the way down here. And we'll just finish the loop. So it's going to be exactly the same as what we did before. We can just go, let's call it a pixel, a pix. And we're going to make it equal to new image, which is our image. And it's going to be equal to 1, R. So it's going to do first column, and then it's going to iterate down for each row. Sorry, that should be the other way around. First row, second row, third row, etc., and the first column. And then I want to add 1 to it. The reason for that is because all the numbers in this map, where is it? Hold on. There we go. So new image is between 0 and 7. So I'm going to increase that by 1 like I did before, because in arrays in MATLAB start at 1, not 0. So let's run that. And we'll print out row prob. And it's all zeros. That makes sense because I didn't save those numbers into the array yet. So let's do that. That was pretty pointless. Row prob. So row prob a pix, which is going to whatever number gets returned between 1 and 8. because it's 0 to 7 plus 1. I'm going to make it equal to itself and add 1. So it increases by 1 for each occurrence of each color. Should be good. Let's try and run that. I'll close that off. Yeah, that'll be fine. Run. Get my image. And no errors, which is good. Row prob. Yep, there we go. So it worked. It went all the way down this first column and saved in the numbers. So it looks like 142 is probably white because there's heaps of white. And then we got like some other colors, like I don't know, 5 of yellow, I guess, for his foot or his mouth. So that looks like it worked for the first column, for the first row. Sorry, it went R is equal to 1 all the way up to 161. So it went row 1, column 1, row 2, column 2, row 3, column 3, etc., etc., etc. That returned a number between 0 and 7. Then I added 1. Then I came down here and found the right index and incremented it by 1 for each occurrence of each color. So now that we have the row probability, we can do the same thing for the columns. It's exactly the same thing. So I'll write a new for loop. I'm going to do it exactly the same. I'm going to say C for columns, 1 cols. So this is going to increment cols amount of times, which is 32. So for each column, it's going to increment all the way, all the pixels. So it'll be exactly the same. We can even copy and paste this, but instead of having row prob, we'll have column prob. So we need to make a new matrix for that. We'll just call it col prob, and it'll be exactly the same. So I'll just copy and paste that. Boom. Alright, now exactly the same. I'll use apex again equals new image. Well, this will be backwards. Instead of having R, 1, it'll be 1, C, because we're going down columns this time. Now we'll add 1 to it, and exactly the same thing as before. Column prob apex equals col prob apex plus 1. So that'll increment by 1 for each occurrence of each color. And looking at this image, it's all white in the top, so it'll come back all white. So I'll run it. No errors again, which is unusual, but that's good. Col prob. Yep, so I got 32 occurrences of this color, which I'm pretty sure would be white. As you can see, this whole top row is all white. So I probably should have called that row prob and the other one column probability, because this one is returning the probability of a row, and it looks like row probability returned the first column. So it's a bit confusing, but I'm gonna leave it like that for now anyway. But you can see how it works. Yeah, that should be called. This should be col, and that should be row, probably. But anyway, I'm gonna leave it like that. So, yep, that's good. So now we know the probability of all of this row, all this column, and all this row. So now we could calculate the probability for the row and the column of the very first pixel. But we need to do it for every single. We need to do the same process for every pixel, and because the way a naive Bayes classifier works is, I'm running out of time. I'll explain in the next video, but we're almost done. Yep, all good.